which of the following fraction expressions are equal? So here we've got quite a few fraction expressions going on. We've got signs going on all over the place. So let's think about this given the way that these are given with their variables, and then see if we can confirm our answer by choosing some particular values. So for each one of these, what we want to do is we want to think about what would be the sign, because each one of these, notice, would have an x in the numerator and a y in the denominator, but where the signs are and aren't is changing from problem to problem. So let's just take a look at each one individually and think about what are the signs going to be here. So for this first one, we have the opposite of x over y. So if I have a negative divided by a positive, that's always going to give me a negative, and then we can move that negative out front, so that would just give me x over y. Now the second one, notice that there's no signs anywhere, so that we can just leave that as x over y. I'm just going to kind of divide these up this way. Now this next one, we have a positive over a negative. So positive over a negative always gives us a negative, and x over y would just give us x over y. Okay. Now this next one, notice that there's a negative in both the numerator and the denominator. And we know from our rules for division, negative divided by a negative is always going to be a positive. And that's going to be x over y. Notice the x and the y don't change there. Now this next one, notice that they're just already giving that little opposite of sign, that negative sign out in front. So there's not a whole lot more we can do to simplify this thing. That's just going to be the opposite of negative x over y. We're just going to leave that one just like that. Now this last one is a bit of a doozy because I've got 3 negative signs going on. So let's just start off by looking at the fractional part. If I've got a negative over a negative, negative over a negative is always going to be a positive. So that's going to give me a positive inside those parentheses. But then remember that we had that negative sign out front that we want to be sure not to lose. Okay? So then if I have the opposite, the negative of a positive, that's going to flip me back to negative. So that's going to be negative x over y. So when we compare these and say, okay, so which ones are equivalent? Well, with blue, we'll circle all the ones that have the negative sign out front. There's one there, there's one there, there's one there, and then these last 2 here also. So all of those ones that are circled in blue, each one of those, the expressions that they came from, all of those, all 4 of those are equivalent to each other. And then for the other ones, notice that the x over y and opposite of x over opposite of y, those guys are also equivalent. Now this can be a little bit messy in terms of dealing with all the variables, but let's just go ahead and put in some values for x and y. And let's choose numbers that make our lives easy. So if we let x equal 6 and y equal 2. So my first one, if we put in 6 for x and 2 for y, negative 6 over 2 gives me negative 3. For the next one, if I just put 6 over 2, that gives me positive 3. Next problem, if I put in 6 for the x and 2 for the y, that would give me 6 over negative 2. Again, that's negative 3. The next problem, if I put in 6 for the x and 2 for the y, I'm going to have negative 6 over negative 2, which would give me positive 3. And then, remember we had the negative sign out front, 6 over 2. So 6 over 2 is 3, but then when I take its opposite, that gives me negative 3. And then finally that messy one, we had the opposite, and then negative in the top, negative 6, negative in the bottom, negative 2. Negative divided by a negative is a positive 3, but that negative sign there needs to come along and turn that negative. And so we can see the same correlation once I use the numbers instead of just the variables. The same 4 are still equivalent to each other, and these 2 here are equivalent to each other as well.